Hello, everybody. This is Nicoleta Cristia, your host of the Waterhackweek webinar series. I am here again at the eScience Institute with Valentina Staneva. Valentina is a senior data scientist with the eScience Institute. She has background in math and statistics, and now is acting as a data scientist, helping everybody with data science needs. Valentina is an expert in version control and Git and GitHub workflows, and I'm very happy to have her here explaining you these workflows in preparation for Waterhackweek.
Hello, everybody. Yes, I work at the eScience Institute with people from many different domains, and from oceanography, neuroscience, and so on. And one of the hardest things we've seen is how to actually work together on collaborative projects where we all should contribute to the same code or to the same documents. So that's what this tutorial today is about. We are going to learn about version control and how to use Git and GitHub to actually help us work together, share code, and publish our results. So the plan for today is the following. So first we'll just discuss a little bit what version control is, what Git is, what GitHub is. And then we are going to learn how you can track the changes in your code and understand the different steps of the process. And then we are going to learn how to explore a little bit the history of your code. And in the end, we will discuss how to collaboratively work with others, which is kind of the most important thing, especially for Waterhackweek, because you are going to work on teams with other people. So it's very important that you understand these concepts so that you can be efficient in working together. So today we'll try to learn a little bit about your experience too, and for that we have some simple through the tutorial. We have some simple questions like quiz questions, and for that you can answer them by raising your hand in the GoToMeeting software. So just to this kind of, in some sense, we'll test this approach with the first question, which is simply about your experience with Git and GitHub. And so let's see, like, how many of you have not used Git or GitHub before? So try to see if you can raise your hand. So the hand should be next to your name on the GoToMeeting. Okay, so we see some hands. So this would be your first experience. And just to warn you, for those who have not used it before, usually there's a lot of concepts coming in, so it's a lot of material. But I think as you practice, we'll have more tutorials as we go. You'll learn it on the way. How many of you have used Git and GitHub only for your own personal project? Okay. Okay, so Nicoletta is helping me counting how many people, like 5, 6 more people have used them for their own projects. And how many of you have used you've used Git and GitHub to collaborate with others? So around 7 people have done that, and those who have collaborated with others most probably know that it becomes kind of hard, and maybe then you kind of start to appreciate what we are going to discuss. Okay, so let's move on. In the future, you'll have quizzes, and you can use your hand to answer the questions. Okay, so let's start with this PhD comic, which I think a lot of you might have seen. It's pretty famous, and I think a lot of you might have seen in your own experience. I definitely have done that, basically try to keep on renaming my file with my versions, and at some point I have version 1, version 2, version 3, and at some point I'm just confused which version is really the last version. So as researchers, I think we have a few very simple goals. We want to keep our documents safe. We want to, if we need it, we want to be able to retrieve old versions, and we want to be able to share and collaborate with others. So we need some system that can help us with that, and Git and GitHub is one approach of doing this and avoiding what happens on the right side. So a little bit more specifically, what is really Git? Well, Git, instead of doing what this person is doing, basically making copies of each file and renaming them, Git is actually trying to do this automatically. So it's a software that works locally on your documents, and every time you make a change in your document, you have the option to record this change, and Git would detect these changes and will store only the increments. So in a sense, you store the base version here, and after that will store only what was changed. So that's pretty nice, because in this case you don't have to end up with 100 copies of your document. So it's also more efficient space-wise, but it also can point you exactly to where the difference is. So it's and it works with kind of trying to combine changes from different documents. And what is GitHub? Well, GitHub is actually a web platform which kind of facilitates the process of using Git. But right now, I would say it's way more than that. It's become really like a collaboration tool that's used by many people across the world. So it's more of a social network for software engineers. And you can see this is just an example of a repository online for the HydroShare project. And you can see that there are like 32 contributors, and it's all public. They are people from different places. They don't work at the same university. So they have the code here, but people can star the project if they like it. They can submit issues if they see some problem. So you can see that it's much more than just putting your code online. Okay, so now let's compare to what we kind of other options that we can have. And one of them is, well, why don't we just use Google Docs or Drive or Dropbox? So what is the difference? Where they also have some, basically you can see the changes, but the changes are indexed by time. So if you have a lot of changes, at some point you have a very long list of all these changes. And if you remember which version you want from which time, that's nice. But if you don't, it's a little bit hard to parse, because you have to know exactly which time this thing was changed. And also there's some limitations on how many versions. Sometimes they just allow you to have 1 month backwards, so you don't have the older versions. And Git and GitHub, well, it's different. You kind of, Google Docs is perfect when you write documents with other people. Git is very good for code, not so good for like writing maybe a paper. And the reason is that Git is more strict about how you save your changes and versions. So, and it's more strict about what is getting accepted in your code and what is not getting accepted, which is good for code, because you don't want to break something by mistake. And the versions are named by you, so you have more control over it. And there are no limits of versions, so you can go backward and see the project from the very beginning. All right, so this is kind of the general overview. And now we are gonna get to really, I'm going to show how you actually do use Git and GitHub. And you don't have to do this now. These are the prerequisites to actually get things working on your computer. So you can kind of do this later on. For now, I have already installed everything on my computer, and I'll just kind of walk you through the steps. And in general, what you need is you need an installation of Git. You need to make an account on www.github.com. And usually you need to have a working terminal and some text editor. And I'm using Nano, and you'll see how it looks from the terminal. But you can actually use a different editor if you don't like it. Okay, so let's get started. So the first step is we are going to create a new repository. So a repository is the name for your project. And basically, and we're gonna add some code to it. And when you log in kind of into your account, you can see this plus sign over here, and you can select a new repository. So I'm gonna switch out of here now, and I'm gonna go back to my own account, and I'm going to hit the plus sign, and I will create a new repository just for this exercise. And I'm going to call it my first Git repository. And I'll basically follow kind of what they ask me here. So they ask me whether it's public, I'll make it public because I want to share with you. And I'll initialize with the README so that I just have a little description of the project. And I'll hit create repository. So now you can see this repository here. There is nothing there. There is only this little file that automatically puts the name of the repository. So there's no text yet. So now how do we, so this is on the website. How can we actually add more things to this project? Well, the first step is to sort of link what's happening on your computer with what's happening online. So in order to do that, we will clone this repository to a local folder. So for that, you come here and you see this clone or download. Instead of doing any of those, all you need to do is copy this link. So basically, this is the link to the address. It's the same as this link over here. So once you copy it, you can go and you can go to the folder where you want to work from your own computer. And I'm going to work in this teaching folder. And you can see that Git is installed. So there is like, if I just hit Git, it's working. So you can check that first. And I will type git clone, and I'll paste that address. So basically, in my case, this repository existed before, so just remove it very quickly. In your case, you won't have this problem. So there's a lot of small objects that I'm removing. Okay, so now if I do git clone, it's creating a new folder. If you don't have this folder, you won't have the problem I had. So you can see that now I have somewhere here, I have a new folder that's called my first Git repository. Okay, and I will go to this folder, and from now on I'll work from this folder. So now I can see what's inside, and I can see that I have the same README file that was online, and basically now I have the two repositories sort of linked, so I can work locally and I can publish the changes online. And so just to show you how I'm going to use the text editor, I can just type nano and the name of the file, and I can actually see what's inside this file, and I can make changes. So you can try it out and see if you like it, or you can select a different text editor. But this is the one I'm going to use. Okay, so now let's add some code to this document. Okay, we're not going to add a real code. We're gonna add some text so that we can see exactly what's going on. So I will open this file, and I will. So let me kind of first overview a few of the steps. So So you could see that we had this GitHub repository online, and we used the git clone command to move everything locally to our laptop. So this is always kind of the first step. And then there are several steps to actually add code to a repository. And I'll first describe them quickly, and then we'll do them from the computer. So kind of the idea is that first you make some changes in your code, then you have to select which file changes you want to add, and then you are going to take a snapshot of all the files that you are happy with at some point, and then the final step is to publish everything online to GitHub. So this is kind of the process. There's quite a few steps, but we'll go over through them now slowly. Okay, so I have this document, and I will just write, I want to change the title because it's not very good. So I'll write welcome to my project, and maybe I'll have a little description. This project contains my dissertation. So you want to keep it safe, so we save that and exit the terminal. So now I have made this change. So I mentioned that Git kind of tracks the changes automatically. So let's look at how that works. So if I just type git status, it shows me that this file readme is modified, and it shows it in red. So there is some change. And if I want to see what the difference is, I can use git diff, and you can see how Git detected what changes were made. So here it says that it's in red, which means that it got removed. It removed this line, and it added the new description. So how can I make these changes viewable actually on the website? Well, there are several steps. The first step is to tell Git to track this file. So basically, I'll use the add command. So this means that I'm going to add this change that is red here. And once I do that, I'll type git status, which you should do very often just to remind yourself what's going on. So now this change became green. So this means that the change is seen by Git. And then the next step is that I want to make a snapshot of my repository at this moment. To do that, I use the commit command with -m, which stays for a message. And I'll write a message to remind me what this change was. And I'll write wrote an introduction. Okay, and then all these git add and git commit, it acted locally, and the final step is to add this to the website. So the command for this is git push origin, and it tells us that it's kind of working on it. So let's see what happened over here. So now we can see the change on the website. So let's kind of revisit this for a second. What was this weird thing called origin? I'll just show you. If we do git remote -v, we see that origin corresponds to the address of the website. So in some sense, basically we say git push origin means git push to this address. If you change the address, you push to a different address. So basically this says publish to this website. Okay, so let's go back and discuss these steps a little bit more, because they're kind of important. We saw that how basically there is an adding stage, and then there is a git commit stage. So this is a little bit confusing for people, because they are like, well, why do you need these two steps? Why can't you just do it one way? So git add basically adds your files to something that is called staging area. And you can think of this as like, suppose you're preparing to go on a vacation to Hawaii, and you have your suitcase, and you are putting different items in your suitcase, trying to get ready. Your suitcase kind of stays next to the door. And every time you have a new item, you use git add to add this item to your suitcase. And then if you forgot something or you change your item, you can keep on doing this. But in some sense, you're just getting ready for your travel. And then when you do git commit, you can think of it as now you take your suitcase and you zip it. So it's now ready to go. And you put a lock on it, so you kind of have like a snapshot of it. So in the future, you can actually go back to it. So that's how these two steps work together. And then if you have other suitcase, you can kind of have more commits and repeat the same process. Git add, git commit, and once you're ready, you can push and everything goes on the website. So this is the general process, and you need to practice a little bit yourself and you'll get used to it. Okay, so let's just kind of now have a little bit of a quiz so that we see whether everybody understood these steps. So what is the output of the file after the following steps? So let's say that we just write first line in this README document, and then we run the command git commit -m, adding first line to README, and then we write git push origin. So what is the output of these three steps? So the first option is A, which is first line, and the second option is B, which is blank. So how many of you think A is the right answer? Okay, so I don't think this is from before. No, they appear in me. Okay. So 5 of you think first line is the answer. How many of you think blank is the blank is the answer? Okay, many of you think blank is the first answer. Okay, so let's discuss. The correct answer is blank, and the reason is that we wrote first line, and then we committed the state of the folder, but we forgot the git add. We actually forgot the git add command, which means that this change, although it's changed in the document, it was never really, Git didn't know we should add this change. So then git commit and git push, although these commands worked, they didn't really take into account this change. So the document remained empty. So basically remember too that if you have a new change, you have to add and commit and push. So blank is the answer. So okay, so let's discuss a little bit how we explore the history. So every time you make a commit, you get, on one hand, you get this message that you have written. So initial commit, or you can call it the way you like so that you remember later on to go back to it. But you also get this number that corresponds to your snapshot in some sense. So that's good because we can also refer to things by the number. And there is something that it's called head. Don't worry too much about it, but this is something like pointing where your current state is. So in the beginning, it's pointing to the first commit, then it points to the second one and the third one and so on. So the idea is that this head kind of keeps on moving with each version, and you get a number for each one of them, and you get the message. So, and the good thing is that you have all of these saved, so then later you can go back and you can revisit these versions. So let's go back now to our repository, and let's add a few more commits so that we have more versions. So first, if I just do git log -one line, that shows me that I have an initial commit and I wrote an introduction. So let's say that I keep on working on this document, and let's say that I add first, let's say this is the abstract of my dissertation. So I start adding more content, and I can do git add, readme. I can look at status so that I remember what's going on. It's green, so I can do git commit, adding abstract, and I can stop here. Let's just look at git log again and see what happened. Okay, so now I have, you see how each one has this little number and it has the commit message. And let's say that I messed up something with the abstract. I went to my advisor, they said that it's really bad, I just want to throw it out and start again. So in this case, like in some sense, I just want to go back to this original version and I want to remove my last commit. Maybe I made a big mistake. So how do I do that? Well, one of the easiest ways to do is to use the git revert command. So I can just write git revert head. So basically, this will go back one commit backwards. And because I'm kind of changing a little bit the traditional workflow, it also wants to record this message while I'm doing the commit. So it says that it reverts this commit. Okay, I agree with that. And let's see what the history looks like after that. So now you see what happened is, instead of having two, I kind of expected to, you can think that maybe you want to just go backwards to here. But instead, what happened is we have the initial commit, we have the road introduction, we still have this adding abstract, and we have revert adding abstract. So we added actually an extra commit. So let's see what happened to our dissertation. Well, let's look at it. Based on the document, it did indeed basically revert this last step. So in practice, what happened is, instead of removing this commit completely, which is a little bit dangerous, maybe you change your mind at some point, git revert is actually a very safe way to go backwards without really like removing things completely. So basically, it went back and it created a new commit, which is exactly equivalent to that version. So in some sense, it increased the number of versions, but on the other hand, we're safe because we know that for sure we didn't lose anything. So this way you can actually revert several commits if you want to, or you can even have the option to check out a few specific commits and just look at them, or just a specific file. So, and all this, if I go back and if I push these changes to the website, you can also explore what's happening from the website. So let's wait. So let's do that. So now we have 4 commits here. So we can also look at the history from the website, and you can see they have the snapshots, and kind of you can click on it and see what the changes are. So it's kind of, actually the website is very nice to look at the differences between the files. So it reminds me what has changed from step to step. Okay, so this is how you explore history. So now let's have a question. So git revert head. So option A moves the head to one commit backwards, creates a new commit that looks like one commit backwards. So which one is the correct answer? So how many of you think that A is the correct answer? So a few of you. How many of you think B is the correct answer? Many more. Okay, I think B wins in this case. So yeah, as we discussed earlier, we revert actually doesn't just go backwards, it actually it creates really a new commit and moves the head to this new commit. So it's pretty safe. Okay, so let's move on. So now we're going to discuss a scenario that happens often in your real life, that you work on your laptop, and we just learn how to, from your laptop, you can make changes and push those changes to the GitHub website. But what if you work on your desktop in school, and you kind of, you want to work on your laptop, and in school you want to work on your desktop. So you kind of want everything to be synced, right? So you just go to the new computer and all the changes are there. So how can you do that? Well, the first step is to use this clone option and clone this repository on your desktop too. So that's kind of the first step. So now you have copies, cloned copies on your laptop and on your desktop. And then the second step is you can kind of work here now on your desktop, and that's fine. And you can, as before, you can just push your git add, git commit, and git push your changes to the website. So this is something you've already done. Now the question is, you go home in the evening and you want to get all this new work, you want to see it back on your laptop. How can you do that? Well, for that you need to use the command pull, which is kind of opposite of push. So pull just gets all the current version that's on this website, and you bring it back to your laptop. And then once you do that, you can again push and then pull again. You go to the other computer, and before you start working, you pull again and push and so on. So this is kind of the process. So let's just do a very quick example. So instead of using two computers, I'll just make a change on the project from the website, and I'll try to bring this change down to my computer. So I'm gonna write here first step to success. So I will save this directly. This is just a quick way. So sometimes if you just find a typo, you might just want to change that typo from the website. But how can you bring this typo back to your computer? So now if I do a git pull origin, it tells me that it added two insertions. And if I open the file, you can see that first step to success appears here. So this is kind of the process to bring changes from the website. Okay, so the next step is to do something to now actually work with a collaborator on the same project. So this is actually very similar to the way you do it when you have two computers, like your desktop and your laptop. It's just the only difference is that we will have to make the collaborator, we have to give some permissions to our collaborator. So I'll first go and go to my repository, and I'll make Nicoletta my collaborator because we want to work together on the project. So you have to go to settings and collaborators, and I'll add her name, and Git finds her information, and I add her as collaborator. So keep in mind, when you do this usually takes a little bit of time, and your collaborator have to find the email invitation so that they get permissions to your repository. So in this time, Nicoletta will accept my invitation and just work on this repository, and in the same time I will work on the same repository too. So the idea is the following, that basically I'll be doing my changes and she will be kind of working, she will clone the repository the same way that I did it on the new desktop, so that she has a copy of it too, and she'll work on her changes and I'll work on my changes. Okay, so in the meantime, I'll just kind of work on my own work, and go here and start adding more work. So I'll open my file and I'll add adding Valentina's ideas to the dissertation. Okay, so yeah, I'm adding more. I'm just working on my document by myself, and I will go through the typical process.
Well, in the meantime, I received the invitation. I accepted the invitation. So now I'm working on my document on my own. And I'm making the changes, I'm committing the changes, and I'm pushing the changes back on GitHub.
So that's usually, it doesn't matter what time these changes are made, because the idea is that collaborators can work at different times. So it's not about who is first and who is last. But the idea is that we both can contribute to this document. Okay, so I just keep on doing my workflow. So let's see if that would work. Should be on the same line. You did it on the same line. Okay, I'll add something on this. Okay, so I'll just modify something. Okay, I'll just make my change this way. So I'll add it. I'll commit the change. And I'll try to push as usual. Okay, so it's good. Actually, Git complained when I tried to push. And the reason is that they're already new. It tells me that there are new updates that I don't have yet. So first, you need to integrate the remote changes. Well, we just learned how to do it with the git pull command. And Git tells me that it cannot automatically pull those changes. The reason is that we deliberately with Nicoletta try to change the same line so that we actually have something that's called a conflict. So if we now look at this file, you see that basically there's some change in this file that neither of us made. So basically there are these weird signs, head, and all these arrows. Those were created by Git. And you can see there is my version here, and then there is Nicoletta's version here. And Git is not sure which version to keep, so it lets us decide. So, and we can do this manually. So now I'm opening the file, and I can actually decide I want to keep both mine and my collaborators' ideas. So I do. Oh, I
want success.
I want success.
Yeah, keep it there.
So I keep all the changes because I like all of them. But if you don't like one part, you can actually remove one part. Okay, so now we'll save this document, and we're gonna continue with the process as usual. I'm just gonna add the file, I'm gonna commit, and when I'm resolving a conflict, I always call my message resolving the conflict, keeping both changes. Okay, and we can actually push this change. And now there is no problem because the conflict was resolved. And also you can just pull to make sure everything is updated, and pull would also work because everything is up to date. So this was so the process was like before. So everybody needs to pull and everybody needs to push, and you should make sure you pull before you push. And if you get a conflict during the pull, the idea is that you kind of have to go through the steps to resolve the conflict manually. And this is very important because often when you work with other people, this happens. So you have to have a way to get yourself out of this situation. Okay, so we'll have a quick question now, just do like 2 questions. So the first question is, changes made to different files do not result in a merge conflict. Do you think that is true or that's false? How many of you think that's true? So a lot of you think that's true, and that's the correct answer. So usually if people work on a different document, there is no problem. So I work on mine, they work on theirs, all changes will get accepted. So the next question is, changes made to different parts of the same file do not result in a merge conflict. How many of you think that is true? So a few of you think that's true. The answer is that usually that's not. Usually that's true. And the reason is that Git can kind of parse the file, and if things happen at different places, it's actually okay. So the only time there is merge conflict is when things happen to the same lines or to the same place in the file. And sometimes it happens that there's some formatting issues. So maybe one of the collaborator changed the formatting of the white spaces. So it might actually happen, but in general, it shouldn't. So just keep this in mind. Only when you work on the same part, that's when you get merge conflict. Okay, so now I'll just briefly describe a process that's a more complex workflow, and that's useful when you don't have permissions to the repository that you work on. And this is kind of when how Git and GitHub are really powerful, because you can just find a repository that you like online, and you don't have permissions for that repository, and you have the opportunity to actually contribute to this repository by just suggesting your work. And kind of the process is called, so because you don't have permissions, what you do instead is you actually make a copy of that repository using something called forking. So you basically makes a local copy, makes a copy for you, and then you can work on that copy because you have permissions in your copy, and then you can use the pull request option to suggest for the maintainers of this main repository to bring your changes. So I'll just briefly show you how that looks like, but you can practice more by yourself. So like I'll go to this repository, which is on the Waterhackweek website, and there is a Git practice repository, and I don't have permissions to it, and you don't have permissions to it, but you can actually do practice there by clicking on this fork button. So I'll fork it into my name, and it makes this copy, as I said. So, and once you have a copy, you see that here now I have Valentina-S, and I have a repository with the same name, and it tells me it came from Waterhackweek Git practice. So they're kind of linked, but they're different repositories. So what I can do is I can work in this repository. So, for example, I can make a little change here. New contribution from Valentina, and I'll commit these changes. And then if I go to the kind of here, the main thing, it's going to tell me that maybe I'm happy with these changes and I want to suggest them. So it says that the branch is one commit ahead. Yes, I made a new change. And I can use this button, new pull request, to actually ask these people, do you like my change? So basically, I'm going to, I'm suggesting a new contribution. Please accept it. Okay, so I'm gonna click on this, and basically the maintainers of this repository can see that there is basically just to this repository. It's for practice, so you can use it yourself. And I'll skip this question. You can try to think about it yourself. It's about the difference between clone, poo, and fork. They all sound a little bit similar. But I'll just end with summarizing some resources for you so that you can, if you want to learn more, you can practice. So kind of my approach of teaching is mainly using the software carpentry lessons, so you can go backwards and read everything carefully and do some of the exercises from here. You can use Code Academy to actually test your knowledge. You can actually try out things on their website. And Atlassian tutorials are extremely great if you really want to understand things more in depth. So there are more advanced topics there. And this is a guide which allows you to learn a little bit, very quickly learn some of the more advanced topics also, but kind of through visual explanation. And the last thing is that just would advise you that you just look at one of these cheat sheets and just print it out and put it on your desk, because we all forget all these commands, so we have to Google them all the time. So just keep it on your desk and practice, and you'll get used to all these commands. So I'll stop here and I'll ask if there are some questions.
Thank you, Valentina, for the wonderful tutorial. Please practice using the Git practice repository on the Waterhackweek GitHub website, and type your questions in the box if you have any. So Christina is asking, where do I find links to get more practice? So I think Valentina just showed a few of them, and we will post her slides on the Waterhackweek website that was also updated to include the previous tutorials with the videos and GitHub repositories.
So yeah, we'll share the slides so that you have them, and maybe we'll put them on this Git practice repository so you can easily find them.
Here's a question from Shelby. If I have a Windows operating system and usually work with command, do you recommend installing some sort of bash terminal to work with Git?
So yeah, so in this kind of in the slides backwards where you have the instructions, which might take a little bit time to get there, but they have explicit instructions for Windows, Mac, or Linux. And for Windows, you have to install something Git for Windows, and that comes with its own bash. So you won't be using the. So here, I think they're the instructions for Git. So basically, you'll be using Git for Windows comes with its own bash, and you'll be using, when you run these commands for Git, you're going to be using their bash for that. So that's the special thing about Windows. So basically, as long as your bash is working, you make sure that the Git command runs, you can actually use that. Sometimes you have a bash terminal, but they are not linked to Git, and I think that simplifies the process by just using their bash terminal. But yeah, there are instructions for each operating system. So
Here's another question from Johan. If my local Git repository is in my Dropbox and it syncs with my other desktop, do I need to clone or pull again, or I can just edit in my Dropbox?
Okay, so that's a very good question. I've tried to do that, and you have to be a little bit careful when you have two version control systems working at the same time. So I think it's going to work if you work only by yourself. So you basically you keep your things in the Dropbox. Basically, I showed you how to clone a repository from the from GitHub just because it was simpler, but you'll have to do the reverse step of now you already have your repository. Just using the git init command, you can publish it online. So you'll not clone it. You'll start with the one you have, and you'll make a web version of it. So basically, git init is the command for that, but you can read about it a little bit. So you don't have to clone it. So you'll use it, and you'll have to be careful because I think if you work with two people, it may become a mess. I have to admit, I tried that and it's kind of hard. But if you only work by yourself, then occasionally you can make commits with Git just from time to time, and then use the kind of Dropbox option to back up everything all the time. So this was my approach, and it worked because only I work, so there's no new changes. If there are new changes from other people, Dropbox will automatically make these changes. So it a little bit defeats the purpose of having the pull command. So it becomes a little bit two things happening, making changes in your repository at the same time. So I think it's a little bit trickier. So I would use this approach if only I work on the project, then it's kind of fine. But if you have several people, it might be hard to keep both of them at the same time. The other option is sometimes people use Git. Basically, they have a copy. They have like they just sync occasionally with the Drive or Dropbox. They don't do the automatic syncing of the two documents. They just occasionally upload things to Dropbox. So this is another approach. So yeah, it kind of depends what you like.
Here's another question regarding Windows machines. Is Git Bash or Cygwin better? What are the trade-offs for different terminal options?
I would use Git Bash. I know that Git works automatically on it. I know now Windows 10 has kind of, I used Cygwin before, but I haven't used it recently. And I think now with Windows 10, they have their own Bash built in. So maybe that can also be another option and you don't have to use Cygwin. But yeah, I think like Git is working perfectly with the Git Bash. And I think if you try to use Cygwin, you should just make sure that it is the Git command works. So maybe there's some path. Basically, you have to set the path to the Git installation. The only advantage is that with Git Bash, it's doing it automatically. So that's kind of the thing. So yeah, I agree that some of the other Bash have a lot of nice options, but I think now with the newer versions of Windows, you can have a full Linux terminal that has all the options. And I don't know about you know, like whether we need to use Cygwin anymore. I guess that's something I don't know. Maybe it's okay now to just switch to these other options.
I seem to remember that there was a Git or GitHub product release that works on Windows machines that's Windows based. So you actually go and click and add manually the files through a Windows interface.
Yeah, so I guess that's another point maybe some of you are wondering about. I didn't talk about, there is something called Git desktop version.
Yeah.
So, and I didn't talk about it, and the reason is because I kind of wanted to teach you kind of how things happen from the terminal when you have full control over everything. The Git desktop, What I've heard, it works well when you just use the very simple features like add, commit, and push, and works well when you work by yourself, because kind of the process is very standard. I've heard that once you start working with other people and you start to do more complicated stuff, they might not have those commands built in, so you kind of have to resort to the terminal. So that's why in our approach we directly teach you how to do things from the terminal. It's kind of same with the website. You can do some things directly from the website. But what we've learned that sooner or later you have to do things from the terminal because you have to resolve some complex merge conflicts and so on. So, but I think if you're just getting started and you want to try it out, you can see how it works for you. And the only thing is to be careful because they kind of try to simplify things for you. So just don't forget about the important details that you have to be in control of your code. Like you have to decide what needs to be synced. So don't rely too much on it that you think that it was synced, but actually it wasn't. So just check the history and make sure that everything works.
Here's another question from Shelby, and that's like, it's very important to address because it happens all the time. So the question is, with collaborative projects, do you ever run into problems with people editing projects with different versions of Python, or is there some check-in place to make sure everyone is working with the same packages or versions?
Okay, that's a very good question. And I'll go to a big project. Let's say I go to Scikit. I'll try to find scikit-learn, which is clearly a big collaborative project, and people try to do things to make things work on different versions also. So I think the first simplest thing is to decide on a version you work on. But here and there, some people's system might get outdated. So even if people decide on Python 3, there might be some slight differences. So you can see that here this is a big project and they have all these build passing, build pending, and so on. So in order to deal with different versions of code, so you see how you have Python 3.5, and so basically there's something which is called continuous integration. So this is more about testing your code, which is very important, and it's kind of like a whole another topic that we can have a tutorial on. But when you write code, you want to have some tests built in, and basically you want to set up a system, which, for example, Travis CI is one example of a system that can test and deploy your code. So the good thing is that they work very well together with, so basically you just run tests and you can kind of specify what versions you want this code to be tested on. So you can have tested against Python 2.5, Python 2.6, and so on. So, and the good thing is that they integrate with GitHub. So you can set it up so that every time a new person makes a push, they will they'll trigger this testing, and if there is a problem, it's gonna be obvious. So the maintainer might not accept your code until you make it work with the versions they want. So this is how really code is written like in production, because you cannot just expect people to add new changes and break your code every time. So, and it's really nice that if I try to submit a new pull request, somehow it's gonna be it's gonna check all the versions, and it's gonna tell me if there is a problem with the test. So this is kind of a whole another topic, but the good thing to remember is that you can integrate this with GitHub. So you need to pick it's called continuous integration. So there are different Travis CI, there's Circle CI. So you just need to pick one and you have your own tests.
Okay, everybody, I see no more questions, and I thank Valentina again for the Git tutorial, and I will meet with you next week for the Land Up seminar. Thank you. Have a good day.
Thank you. Good luck with your projects.